Ladies and gentlemen, boys and girls, welcome back to the Muscle Intelligence Podcast. As always, I'm your host, Ben Pakulski, getting to the bottom of the most pressing topics to ultimately help you look, feel, and perform at your best. One of the things that's afflicting men and women, certainly of any age, but definitely over the age of 40, is the conversation around nitric oxide. Most people may not have heard of nitric oxide. Many of you have. Nitric oxide is ultimately this gas that's produced in every one of our cells that helps us dilate our blood vessels. Dilation of blood vessels is obviously incredibly important to literally the function of every cell. If you want to think well and focus well, if you want your heart to work well, if you want your muscles to work well, if you want your sexual parts to work well, you're going to want to cue into this conversation. There's some very important things shared in this conversation that you may already be doing that may be killing your natural nitric oxide production, and also why you want to really pay attention to sustaining nitric oxide production over the rest of your life. Dr. Nathan S. Bryan joins me today. He is the world's authority on nitric oxide production, and we get into the weeds a little bit. So bust out a pen and paper, but it's definitely incredibly actionable as well as being incredibly scientifically informative. So Dr. Bryan is just seemingly the man when it comes to understanding nitric oxide production. And I asked some pretty deep questions. So I suggest you do not listen to this podcast on rapid speed because we are moving at a pretty quick pace in the podcast itself. Today's podcast is brought to you by me and the team at the Muscle Intelligence Coaching Community. Gents, we are working specifically with men over the age of 40 to optimize the way you look, the way you feel, and the way you perform. And we're doing it at the highest level possible. I like to say we're treating all of our gentlemen like gold medal winning athletes. We're going to look at all of different aspects of health and performance and longevity to ultimately allow you to show up at your highest and best for what matters most to you. So many of you are confused. So many of you want someone to pass some of the responsibility to ultimately understand, what should I be doing to make sure my body looks great? What should I be doing to make sure my body functions really well? And ultimately, what should I be doing to make sure that I'm moving in the direction of longevity? We are not diagnosing disease. We are not treating disease. We're ultimately looking for performance opportunities so you can show up at your highest and best for what matters most to you. What matters most to me? Family. What matters most to me? My business, my community, my clients, people I truly care for and love and respect. And I spend an ungodly amount of time researching and understanding ultimately how to optimize the human system so that we can live long and be strong. So gents, if you're interested in working with myself directly or my incredible team of coaches from all around the world here at Muscle Intelligence, we have an incredible 90-day program that we're launching now. We're calling it a 90-day intensive. Intensive meaning we're going to get you in the best shape of your life, or at least the best we can over the 90-day period. But mostly what's going to happen is you're going to understand the operating system that you're going to need to take with you to move forward to optimize the 16 hours that we're awake. And so we're awake for 16 hours, and there's a certain small number of things for you that you should be doing every day to ensure that you have the energy to perform, that you have the focus to perform, that you have the vitality to show up at your highest and best. If you're interested in working with us here at Muscle Intelligence, head over to muscleintelligence.com/apply. If you're not ready to work with us, but you're curious, head over to muscleintelligence.com and fill out an application for our newsletter. I'm actually starting to be personally writing the newsletter again. Twice a week, Tuesdays and Fridays. I'm committing to doing a deep dive on Tuesdays and then kind of a 5-bullet Friday style format on the weekend or into the weekend, so you can see what I'm reading, what I'm studying, and the most pressing things that are coming up in my life that are ultimately designed to help you. Head over to muscleintelligence.com and sign up for our newsletter there. Gentlemen, enjoy the podcast with Dr. Nathan S. Bryan. Yeah, you're the nitric oxide guy. When that word comes up, your name isn't far behind. So that's I'm really excited to dive in. So, and a little bit about me, like background for myself and the audience. I was a professional bodybuilder. A lot of people follow me through bodybuilding as being the intelligent bodybuilder, the smartest guy in the short bus, and now evolved into helping people live longer. Ultimately, right? So as a bodybuilder, you can always do a lot of dumb stuff and it causes a lot of harm. And so it sent me down this path of like, what can I do to help people not make the same mistakes I did? And ultimately live long and be strong. So I'm super excited for the message you're going to share.
Oh, thanks. Yeah, I think, look, there's a lot of things we learn in life, right? Some of it's, from trial and error. And, I think some of the most valuable lessons we learn are from other people's mistakes and what they've done.
Yeah.
So we don't have to repeat that ourselves. So
Yeah.
congratulations on that, and helping millions of people out there.
Thanks. And I try to say that to my kids. I'm like, smart people learn from their mistakes, but really smart people learn from other people's mistakes. And
That's right.
some people don't learn from either, right?
Yeah.
Yeah. So let's dive right into it. Like, I'd love to hear, we could dive into the mechanisms of nitric oxide, because there's so much. It's such a broad landscape. And I think helping the audience understand why this is something that everyone, literally every human, should be paying attention to would be a message I'd love for you to kind of champion for us.
Sure. Yeah. So broadly speaking, the nitric oxide field is still relatively new. It's only probably a 40-year-old science. It wasn't discovered until the 1980s. So now, we're trying to implement nitric oxide-based therapies into clinical practice. That was my role as a basic scientist when I was a professor of medicine at University of Texas Health Science Center in Houston. But I think for the purpose of your audience, what we've also learned is that we can start to recognize the symptoms of an early loss or decline in nitric oxide production, and then take steps to correct that so that we don't get sick, we can live longer and better quality of lives. So what we understand today about, and I'll relate pretty much everything to cardiovascular disease, because it's the number one killer of men and women worldwide, despite billions of dollars in research and 100 years in study and research. It's still the number one killer of men and women worldwide. And to me, that's unacceptable, because everything we know about cardiovascular disease, and really any age-related disease for that matter, or human optimization and human performance, can be traced back to a loss of nitric oxide production. So what is this molecule? It's a gas, and it's produced in the lining of the blood vessels. It's produced in the oral cavity. It's produced in the stomach. In fact, it's produced by most cell types. And when it's produced, it's gone in less than a second. So our body makes it. It activates a number of signaling pathways that are involved in regulation of blood flow, tissue oxygenation, memory and cognition, sexual function, athletic performance. And now it's recognized that when we lose the ability to produce this molecule, that's the earliest event in the onset progression of many, many conditions and symptoms and diseases. And now today we understand that there's a hierarchy, right? And so when we make sufficient nitric oxide, those are the well-trained athletes. Those are the best performers on the planet. When we lose the ability to produce nitric oxide, there's a hierarchy of symptoms. And the first one that typically manifests is sexual dysfunction. So erectile dysfunction in both men and women is a symptom of nitric oxide deficiency. Because what nitric oxide does when it's normally produced, it opens up the blood vessels. And this is all the blood vessels. It's not just the blood vessels of the sex organs. And when you dilate the blood vessels, you get increased blood flow, engorgement, and that's an erection in both men and women. But when you lose the ability to produce nitric oxide, you no longer get the vasodilation. You no longer get increased blood flow and engorgement, and that's the mechanistic basis for sexual dysfunction. So if you have what we call endothelial dysfunction in the sex organs, that same dysfunction is occurring in the coronary arteries and the cerebral arteries, in every blood vessel throughout your body. So if you have sexual dysfunction, that's a symptom of nitric oxide deficiency, and if not corrected, you're leading down a very slippery path of high blood pressure, metabolic disease, Alzheimer's, heart attack, and stroke. And we know unequivocally that loss of nitric oxide is what leads to that. And then second to ED, you start to develop an increase in blood pressure. And today in America, 2 out of 3 Americans have an unsafe elevation in blood pressure, which, by the way, is the number one risk factor for the number one killer of men and women worldwide. And then number 3, you start to develop metabolic disease. Today, it's estimated that 9 out of 10 Americans have some type of metabolic dysfunction. And nitric oxide is required for insulin signaling, glucose uptake, all types of metabolism within the cell. And then fourthly, you start to develop, brain fog, loss of memory, vascular dementia, Alzheimer's. And then you can't perform. You can't maintain an exercise regimen. Because without a regulation of blood flow to the skeletal muscles or to the heart, you can't even sustain any type of exercise regimen. So those are the kind of the short list of symptoms, but those are the major symptoms that affect almost everybody on the planet.
Everyone. Yep.
So what we have to do is just recognize early on those symptoms related to nitric oxide, and then take steps to restore our nitric oxide production.
That's a beautiful segue to my question. Is like, so if we kind of wound back a little bit to the earliest stage or the earliest onset, let's say, of nitric oxide dysfunction, is that something that's happening as early as childhood in some people, or is that something that doesn't usually happen until your early 20s, late 20s? And what mechanistically, what's going on that causes this kind of degradation in nitric oxide production?
Yeah, no, it's a good question. And today we see kids, teenage kids, early 20s, that are reporting erectile dysfunction, that have an elevation in blood pressure, that have adult onset diabetes even in their teens. So yeah, all of these are symptoms of nitric oxide deficiency. So the published data tell us that, the older we get, the less nitric oxide we make. In fact, we lose on looking at population-based studies, we lose about 10 to 12% of our nitric oxide function or production every decade. So by the time we're 40 or 50 years old, we only have about 50% of the nitric oxide we had when we were younger. And that's what leads to an age-related disease. But it doesn't have to be the case. So, we know that, I turned 50 a couple of months ago, but I've got the vascular age and the biological age of a 32-year-old. And to the contrary, we know that there's, 18, 20-year-old kids who have the vascular age of a 50 or 60-year-old. Right. And now we understand what's leading to that dysfunction. It's really the Western lifestyle. It's a sedentary lifestyle. It's eating the standard American diet, lack of physical activity, and a lot of pharmacotherapy. A lot of drug therapy disrupts nitric oxide production. And then also just normal daily habits that people do that's causing collateral damage. And I talk about these all the time. So mouthwash. People that use mouthwash, destroying the oral microbiome that's responsible for the production of nitric oxide, and it's shutting down nitric oxide production, causing an increase in blood pressure. And people that use mouthwash lose the protective benefits of exercise. And this is kind of the jaw-dropping moment for most people because, we were taught through the dentist and through the American Dental Association, well, we have to use mouthwash to have good breath. We have to use mouthwash to prevent getting periodontal disease and gingivitis and cavities. But, that was data from probably 100 years ago. That was before the microbiome project had been completed. And today we understand that the bacteria that live in and on our body outnumber our own human cells 10 to 1. And when we destroy these bacteria, we start to get systemic disease. And there's a reason you don't take an antibiotic every day for the rest of your life because of the damage it does on the microbiome and development of systemic disease. So if you're using mouthwash, you have to stop. That leads to a loss of nitric oxide production. The other thing is fluoride. Fluoride in your toothpaste, fluoride in your mouth rinse, fluoride in the drinking water is an antiseptic, kills the good bacteria. It's a neurotoxin and it shuts down your thyroid function. And then the third thing that people do that most people aren't aware of is antacids. Antacids shut down nitric oxide production. And there are over 200 million prescriptions written for antacids every year, and that's not even counting the people that purchase over the counter. You can now get Prilosec, Prevacid, OTC, and people have been on these drugs for 10, 15, 20 years, sometimes longer. And today we know that people who have been on these types of drugs for 3 to 5 years have about a 35% higher incidence of heart attack, stroke, and 40% higher incidence of Alzheimer's. So things that shut down nitric oxide production are clearly leading to an increased incidence of heart attack, stroke, and Alzheimer's, and metabolic disease. So that's what's leading to the dysfunction. It's really the Western diet and the Western way of life. We drive in our car, we go to our office, we sit for 8 hours, we go home, nobody exercises, nobody sweats. We're eating a lot of processed food that's really depleted of most nutrients. And so, and then the mouthwash, the fluoride, everything we do seems to disrupt nitric oxide production. And that's why we have the sickest people on the planet.
Yeah. So if we were to exclude pharmaceuticals, mouthwash, and say, well, what role does nutrition play in nitric oxide production? So if we talk about, you're talking about standard American diet, eating, making nutrition choices. So I'd love to explore that. Like what exactly mechanistically is killing nitric oxide? But then on the other side of it, there seems to be a lot of things we can do positively to impact the nitric oxide production.
Yep. Now, look, in a perfect world, the human body heals itself. If you give the body what it needs, the human body does its job. But there are two things that get in the way. Number one, the body's missing certain nutrients. And then number two, the body's missing, or the body's exposed to toxins, that even if you have the right nutrients, there's toxins in the environment, in the food, through infections that shut down normal cellular metabolism. So if we just replete missing nutrients and get rid of the toxins we're exposed to, then the human body does what it's designed to do. It regenerates, it repairs, and it's an optimal machine. So in terms of nutrition, since the 1940s, there's a 78% decline in the nutrients, just basic micronutrients in the food that's grown in America, deficient in things like magnesium, selenium, chromium, iodine, basic nutrients needed for normal cellular metabolism. And I think that's why micronutrient analysis is so important in this whole concept of personalized medicine, because the foods that I eat, and we published on this in 2015, that the food grown in Dallas, Chicago, Los Angeles, New York, or Raleigh, there's a 50 to 100-fold difference in the nutrient content of those foods or certain vegetables. So where you may live, your nutrient requirements or nutrient exposure may be completely different than the foods that I'm eating. So the purpose of a balanced diet in moderation is that you get your nutrients from a diverse source of foods so that your body is giving everything it needs to do its job. And I think that's the most important thing. Again, and we understand what nutrients and cofactors are needed to make nitric oxide, and then we try to provide that. And then if you do that, and then get out of the way, stop using mouthwash, get rid of fluoride, stop using antacids, and get rid of other toxins, then the body can make nitric oxide, and the body performs as it's designed.
When you speak about toxins, is there any specific things that come up that are more inhibitory to the body's ability to produce nitric oxide? Because I could hear a lot of people, like in the back of my mind saying, well, what data do we have and what specific toxins? Because that's sometimes a broad field. It sounds like pesticides fit in there because they're killing your bacteria. Yep. But what else? Anything else come to mind?
Well, the biggest villain out there are the herbicides and pesticides, sprayed on the crops. Glyphosate, work by Stephanie Stenoth up at MIT showed that
she's great.
Glyphosate completely uncouples the nitric oxide synthase enzyme, completely disrupts nitric oxide production. So all your GMO food is sprayed with glyphosate. Then when we consume it, it not only kills the bacteria in our body, destroys the microbiome, but it completely shuts down nitric oxide production. So those chemicals are certainly detrimental to the production of nitric oxide. The other thing are like heavy metals. A lot of times the heavy metals aren't affecting nitric oxide production, but they scavenge the nitric oxide that's being produced before they have a chance to reach their target. And 20, 30, 40 years ago, all cavities were filled with mercury amalgam fillings. Mercury is a neurotoxin, and mercury in the mouth, it's liberated every time you masticate or chew, and you get mercury vapors, and it's a heavy metal that's wreaks havoc on the system, and it scavenges nitric oxide. Lead exposure, again, any redox active metal can scavenge nitric oxide production. So those are the big ones. The herbicides, pesticides, and heavy metals that we're exposed to. But there are others.
Yeah, there's nitric oxide primarily being produced in the endothelium. And is there specific things that we're doing that are destroying the endothelium? Because I know it's a very, very sensitive structure, one cell thick. If we could talk about the glycocalyx. But I'm curious specifically, like, if this endothelium exists just inside this tube that is an artery, what is it that's getting in that's destroying the endothelium? So again, it makes sense that pesticides will get in there, heavy metals will get in there. Is that exactly mechanistically what's happening? It's literally getting into the blood and call it disrupting the endothelium?
Well, we know what leads to, so the NOS enzyme is what we call a homodimer. So it's two exact twins that come together that allow for a flow of electrons through this enzyme that oxidizes arginine into nitric oxide. And the rate-limiting step when those components come apart, we call it uncoupling, is the oxidation of tetrahydrobiopterin. So when we have oxidative stress and superoxide radical production or hydroxyl radical, or any redox active reaction that oxidizes a critical cofactor leads to NOS uncoupling. So oxidative stress occurs from inflammation. So there's, the endothelium is, as you said, the single layer of cells that line all blood vessels throughout the body. That endothelium barrier is protected by the glycocalyx, which is a sugar coating that prevents the disruption of the endothelium through the shear stress through normal heartbeats and through normal shear flow. So when you destroy the glycocalyx, then that subjects the endothelium to damage. But restoring the glycocalyx isn't going to restore endothelial function. They're completely separate pathways there. So we understand what it takes to oxidize BH4 to BH2. We understand how to reduce biopterin, tetrahydrobiopterin, and recouple the NOS enzyme. And interestingly, when you restore nitric oxide production, you inhibit inflammation, you inhibit oxidative stress, and you prevent the immune dysfunction that's causal for cardiovascular disease. So simply focusing on nitric oxide production and the restoration of endothelial nitric oxide production completely prevents everything we know about the onset and progression of disease. And that's the remarkable finding over the past 40 years. If we just focus on restoring nitric oxide production, then the body takes care of everything else, because nitric oxide inhibits inflammation, immune dysfunction, and oxidative stress. And those are the hallmarks of every age-related chronic disease.
So you said that the glycocalyx and endothelium are two separate systems. I'd love for you to kind of walk us through that, because oftentimes those get coupled together. When someone's having heart issues, they're like, hey, you got to fix the glycocalyx. Is there no value in paying attention to the glycocalyx, or shouldn't we just focus on the endothelium? Or if you could just walk us through a bit of a
well, I think
on that.
They're certainly both important, and they both serve specific functions. So as I mentioned, the glycocalyx, so there's a barrier, and red blood cells scavenge nitric oxide, so they can both scavenge nitric oxide that's produced, but they can be carriers of nitric oxide activity. And the chemistry, I think, is dictated by this limit of diffusion, or this separation by the glycocalyx from the red cell to the endothelial cell. So if we have a good, healthy glycocalyx that allows for that distance, it prevents the endothelial cells from being damaged by the shear stress, especially when vessels bifurcate. There's some turbulent flow in there that can damage the endothelium. But as long as we have a good glycocalyx and a healthy glycocalyx, then that prevents the disruption or the destruction of the endothelium. But just because you can still have endothelial dysfunction and have a healthy glycocalyx, because endothelial dysfunction is defined by the enzymatic function of the nitric oxide synthase enzyme. So if you have a healthy glycocalyx, but the NOS enzyme is uncoupled, you still have endothelial dysfunction. Now, if you have endothelial dysfunction and your glycocalyx is destroyed or not functional, then you're going to have a higher degree of endothelial dysfunction, because with every heartbeat, you're going to induce some damage to the endothelium, cause oxidative stress, further reduce BH4, and uncouple NOS.
Incredible. So you've become the world's authority on nitric oxide and started creating supplements to start to repair. Well, actually, I'd love to have you kind of parse through. Is it like, am I just when I'm taking a supplement to quote unquote boost nitric oxide, is that boosting my own? Is it healing the endothelium? Is it just boosting my body's natural ability to produce it? Can I lose my ability to produce it because there's so much damage to the endothelium? There's a lot of questions there, but I kind of want to navigate that.
Well, it's not an easy question to answer, because there's hundreds of so-called nitric oxide boosters and nitric oxide products on the market. And I would say 99% of these products don't do anything, because we understand. And so here's what we've done that's different than anybody else. So over 25 years of my research career, we figured out, number one, how the human body makes nitric oxide. We understand what goes wrong in people that can't make it. We talked about the symptoms that arise from nitric oxide deficiency. And so you cannot develop a safe and effective nitric oxide product if you don't understand the biochemistry and the enzymology, and you don't understand the role of the oral microbiome in the production of nitric oxide. So we've studied this for 20 years. We've published on it. And so we know the enzymology, we know the biochemistry, we know the role of the oral microbiome. So now, and only now, can you begin to develop rational therapies. So a lot of products out there contain arginine, high-dose arginine, and some people put citrulline in products. But the human body is never deficient in arginine or citrulline. The body makes it through the urea cycle, and we get it from the proteins. Whether it's plant-based or animal-based proteins are made up of amino acids. Arginine is an amino acid. And it's a semi-essential amino acid, meaning we get part of it from our diet and part of it's produced in the cell through the partial urea cycle. So it makes no sense to give or supplement arginine. The body's never deficient in arginine. In fact, the body's lost the ability to convert arginine to nitric oxide. So arginine, citrulline-based products that are marketed towards nitric oxide are absolutely useless. They don't do anything to restore the production of nitric oxide, especially in a patient with endothelial dysfunction.
Just quickly then, why would someone feel an increased pump or vasodilation from citrulline as far as a product? I mean, there has been I've seen some data, I think, on arginine increasing NO2 production. So I'd be curious where that went sideways.
Yeah, so if you take normal, healthy individuals, younger populations, and you give moderate doses of arginine, you can kind of shift this reaction to the right and get a little bit of nitric oxide being produced out the other end. But these are people that have normal endothelial function. The enzyme that converts arginine to nitric oxide is functional, it's coupled, and you may get a little bit of nitric oxide out at the other end. And it's called the arginine paradox because the paradox lies in the fact that even under steady state conditions, the enzyme that converts arginine to nitric oxide, to get 50% saturation of that enzyme, you only need 5 micromole. But yet, in normal cellular function, and even in sick people, you have 100 to 200 micromolar arginine. So 20 to 40 times higher than what's needed to saturate the binding sites on the enzyme. And the paradox lies in the fact that if the enzyme is already theoretically saturated, why then, if you give more arginine, do you see in some cases more nitric oxide? And in some cases, this is outcompeting an inhibitor called asymmetric dimethyl L-arginine in patients that have an increase in ADMA. Then you can outcompete that reaction with extra arginine. But here's the critical piece, and I think that what people don't understand, is if you have endothelial dysfunction and you take arginine, you can do more harm than good. And this was data dating back to 2006, where they gave L-arginine to people who had just had a heart attack, trying to restore their nitric oxide production, improve recovery from the heart attack. And the arginine increased death and mortality in those patients more so than the placebo. So they stopped the clinical trial because arginine was killing post-infarct patients. And the summary of that study was arginine should not be used in patients that have suffered a heart attack. And then several years later, in 2011, they repeated this in patients with peripheral artery disease, or PAD. And they saw the exact same thing. Patients got worse taking arginine. And mechanistically, that's understandable because you're producing superoxide by pushing arginine, and you're not getting nitric oxide production. The other thing is we start to increase the expression of an enzyme called arginase 2. So you divert arginine away from nitric oxide production and through ornithine and urea disposal. So the body always reacts with what you're giving it. And if you give too much arginine, it diverts it away from nitric oxide. So that explains all the data on arginine. Young, healthy people, you give it, you may get a little bit of nitric oxide. But older people who have endothelial dysfunction, arginine should not be used. In fact, it can cause harm.
Interesting. And citrulline, same idea?
Citrulline, same idea. So citrulline is a byproduct of nitric oxide production. So arginine is converted to nitric oxide, and the metabolic byproduct is citrulline. But then now citrulline has to go back through the partial urea cycle, reform arginine, and so you're at least 5 electrons away from nitric oxide from citrulline, or probably 8 electrons away. So citrulline is a byproduct, and again, it makes no sense to put citrulline in nitric oxide products.
That's so interesting, considering every pre-workout on the planet right now seems to be put in there in very high dosages.
Yeah, and the other thing too is, there's so many other ingredients in these nitric oxide products, right? They got arginine, they got, most of them have caffeine, which caffeine is clinically proven to reduce the perceived exertion of a workout. But caffeine is a vasoconstrictor. So the benefits people are getting from these nitric oxide boosters or pre-workouts may be due to other nutrients, maybe due to the caffeine effect, it may be due to antioxidants. But it's not due to nitric oxide, I can tell you that. But it's not saying that those products aren't effective. And I make a big deal out of this because I tell people, don't get away from what works, just understand mechanistically what's happening. These products may be providing benefit, but the benefit may not be related to nitric oxide at all. In fact, in most of cases, it's not.
So, Dr. Bryan, I'd love to separate this into two kind of directions. First, healing the endothelium.
Yep.
So, and second, boosting nitric oxide production. I'm sure those are very closely related, but for someone who, let's say, is a little bit older, they notice some erectile dysfunction, maybe they notice the absence of vasodilation in different ways, blood flow or whatever, what should be the first steps of intervention, or maybe all the steps of intervention, depending how many there are? Obviously, we know remove the things that are doing harm, change the diet. As far as anything in addition to that, supplementally.
Yep. Well, I think there's two answers. Acutely, so if your body can't make nitric oxide, then you have to take a product that actually produces nitric oxide for you. And that's what we do, and that's what no other company or no other product out there does. But then, I don't want to create a Band-Aid or a short-term fix. We understand what leads to endothelial dysfunction, what leads to loss of nitric oxide production, and we know how to fix it. So we have to repair the endothelium. So number one, you've got to stop doing the things that disrupt it. As I mentioned, if people got to start recognizing, are they using mouthwash? Are they exposed to fluoride? Are they on antacids? And then stop using those. And then there are things that are clinically proven to restore and activate nitric oxide production. Moderate physical exercise, as little as 20 to 30 minutes of kind of, low intensity, aerobic exercise, a brisk walk, a light jog, rowing, swimming, things like that can stimulate and activate nitric oxide production. We and others have published that the mechanism of certain dietary patterns, whether it's the Japanese diet, a plant-based diet, the nitrate that's present in those vegetables is converted by the microbiome to nitrite and nitric oxide that can prevent BH4 oxidation, recouple the NOS enzyme. And the other beauty about certain foods is the high antioxidant capacity that then provides a buffering for the oxidative stress so you don't get BH4 oxidation, NOS uncoupling, and decline in nitric oxide production. So those are the kind of the simple, practical things people can do that's actually cost savings, right? You don't only have to buy mouthwash. You can get off your antacids and then just buy a toothpaste that doesn't have fluoride and just go exercise in the sun for 20 or 30 minutes. And, in most cases, that's sufficient. But when all else fails, then, we have products that do it for you.
So you brought something up there that you hadn't mentioned previous to that, and that's the sun. And that's something that I'd love to dig into if you have any insight there, because it seems like nitric oxide production from sunlight exposure, infrared, and nitric oxide, in my opinion, seem to go up. Is that
absolutely
true?
So when nitric oxide is produced, as I mentioned earlier, it's a gas. But when it's produced, it has certain targets. It can bind to metals. It can bind to cysteine thiols on proteins or sulfur groups. And then when we're exposed to certain wavelengths of light, especially kind of the full spectrum infrared, that frequency of light will liberate nitric oxide bound to metals. And that's why there's blood pressure lowering effects of sunlight. And that's why infrared light therapy is effective. But you have to have sufficient, what we call photolabile stores. So we published on this, I think, in 2001, that there's nitric oxide release, or what's called storage forms of nitric oxide that can be released by certain wavelengths of light. So if you want to enhance the effects of light therapy, then you restore your nitric oxide production through our products or through eating some more green leafy vegetables, and then go out in the sun. So now you've improved nitric oxide production, you've titrated up these photolabile stores. Now when you go outside, you re-release that nitric oxide, dilates blood vessels, improves blood flow, oxygenation, normalization of blood pressure. But you have to have the nitric oxide bound in order for certain wavelengths of light to release it.
What are your favorite dietary sources of nitric oxide?
If we look at what the data tell us, it certainly comes from dark green leafy vegetables on average. But as I mentioned earlier, depending upon where you live, how the vegetables are grown, will determine and dictate how much nitrate's found in those vegetables. But broadly speaking, the darker the green leafy vegetable, the more nitrate it typically has. But, the caveat here is that you have to have the right oral bacteria. So you could eat a plant-based diet and be completely vegan, but if you're using mouthwash or if you have fluoride in your toothpaste that destroys the microbiome, then you're not going to get any nitric oxide benefit from that diet. In fact, nitrate is inert in humans. If you don't have the right bacteria, then you just sweat it out, you poop it out, and it's excreted in your urine. And it goes completely unchanged and unmetabolized. And that's
So that makes sense why
the bacteria.
And that would make sense why antibiotics would kill nitric oxide production.
Yeah.
They're basically killing.
Oral antibiotics do the same thing. They kill the gut bacteria, they kill the oral bacteria, and they have systemic effects.
Super interesting. So one of the things that comes up often in the nitric oxide conversation with men with ED specifically is the use of, call it Cialis, Viagra, all these very, high, call them big lever pharmaceutical nitric oxide production agents. What's your thoughts and opinion on that?
Well, it's a misconception because these drugs do absolutely nothing to nitric oxide. They potentiate nitric oxide signaling. And now let's get a little bit into the science, because I think it's very important for people to understand what these drugs are doing. So when nitric oxide is produced in the lining of the blood vessel, it's a gas, right? So as a gas, it can diffuse in all three dimensions. So part of that gas diffuses into the smooth muscle, and its primary target is an enzyme called guanylyl cyclase. So when nitric oxide activates guanylyl cyclase in the smooth muscle, then that enzyme makes a second messenger called cyclic GMP. And then cyclic GMP is what's responsible for the calcium mobilization, smooth muscle relaxation, and dilation. So drugs like Viagra and Cialis, what we call phosphodiesterase inhibitors. So phosphodiesterase are enzymes that break down cyclic GMP. So nitric oxide increases cyclic GMP production, phosphodiesterase enzymes quickly degrade it. But if you give a phosphodiesterase inhibitor, it prevents the breakdown of cyclic GMP. And so you have prolonged vasodilation, and that's the reason you're warned against 4-hour erections and an unsafe drop in blood pressure, because nitric oxide turns this switch on, and these drugs, the PD-5 inhibitors, keep it on because they prevent the breakdown of cyclic GMP. So you continue to get this vasodilation, smooth muscle relaxation, and that's what sustains an erection. But the data now, 25 years on the market, these drugs were first approved in 1998. And 50% of the men that are prescribed Viagra or Cialis do not respond with better erections. So billions of dollars a year in revenue generated from these drugs, and they only work in 50% of the men in which they're given. And why is that? It's because that the people that don't respond to Viagra and Cialis, they don't make enough nitric oxide to activate cyclic GMP production. So if there's no cyclic GMP around, these drugs have nothing to prevent their breakdown, right? So this tells us, and we've got clinical data to corroborate this, if we give nitric oxide, now you can take the patients who don't respond to Cialis or Viagra with better erections or symptoms of BPH. Now you can make them respond. And more importantly, I think, if you restore nitric oxide, now you can decrease the doses of these drugs, making them, number one, safer, and number two, more effective. But best case scenario, there's never a condition in ED where there's an overactivity of phosphodiesterase enzyme. So giving a phosphodiesterase inhibitor, if you have normal endothelial dysfunction, is not necessary. If we can restore nitric oxide production in the endothelium, in the nerve endings that innervate the penis or the clitoris, and they can produce nitric oxide, you get vasodilation, and you get normal sexual function. So again, these drugs are not nitric oxide donors. They do nothing to affect nitric oxide production. What they do is potentiate nitric oxide-based signaling, and that's the difference.
Okay, that makes sense. So one of the things that came up for me as I was doing some research for our chat is the concept of diet, and obviously the prevalence right now of the debate between vegetarian diet and carnivore diet. And I noticed somewhere you mentioned if someone is, pre-diabetic or has diabetes, a carnivore diet can be okay. So am I quoting you correctly on that? And is the inclusion of vegetables not a requirement for these dietary nitrates?
Well, nobody knows what the long-term effects are of a straight carnivore diet. I think, I'm a meat eater, but my philosophy is that we need to get nutrients from diverse sources of food. So I'm not a big fan of these extreme diets. I'm not a big fan of straight vegetarian, vegan. I'm not a big fan of straight carnivore or all meat diet. I think for certain people at certain stages in their life, they can both be very effective. Because really the data, if you have patients with overt cardiovascular disease, 90% occlusion of the coronary arteries, the data on a plant-based diet at plaque regression and reversing coronary artery disease is pretty impressive. I think we, and in having conversations with Joel Kahn and Caldwell Esselstyn and Dean Ornish, I think mechanistically we all agree that the cardioprotective benefits of a plant-based diet can be traced back to nitric oxide production, the nitrate in these foods that can be converted to nitrite by the bacteria and then regress plaque. So I think in those patients, a strict vegetarian or plant-based diet may be beneficial to avoid, or bypass surgery or putting stents in and reverse disease. But for people with metabolic disorders, I think the data on a carnivore-based diet, because really metabolic disease is caused by sugar and simple carbohydrates and glycation of enzymes and proteins and rendering them dysfunctional and affecting insulin signaling and glucose uptake. So a meat-based diet or carnivore-based diet, which basically is devoid of any carbohydrates or sugars, can improve metabolic function. Now, the question is, can this be sustained for years and years and years and keep healthy people healthy without developing disease? So I think the jury's still out on that, and we just don't know. But people with clear coronary artery disease that put on a plant-based diet, there's very impressive data on reversing disease. But I think in that condition, it's really do or die, right? If you've got 90% occlusion and invulnerable plaque, then you're a heart attack waiting to happen. And then people are motivated because of fear, and they can take on these extreme diets to save their life. But I think what we try to preach is, be proactive. Don't wait until you have a heart attack or coronary artery disease to make changes. Recognize early on when you start to develop these symptoms before the onset of disease, and then take corrective measures then. Be proactive instead of reactive.
How do you feel about Super Green's products in as much as their ability to contribute nitrates? Because, these are, you talk about chewing your food as being able to release these nitrates, and obviously there's no chewing of food going into when you're consuming a Super Green's product or a spirulina or whatever.
Yeah.
Do they still have the ability to contribute nitrates?
They can, doesn't necessarily mean they do. And I've tested a lot of these products. I've tested most beet products out there. I've tested a lot of the greens products. And look, there are other nutrients contained in these vegetable smoothies or green products that are completely independent of nitric oxide. So what we focus strictly on nitric oxide and what's in these greens or vegetables or foods or supplements that can contribute to nitric oxide production. And I would guesstimate that probably 90% of the products out there, whether they're greens or beet products, don't contain any detectable nitrate, nitrite, or activate nitric oxide production whatsoever. Now, it doesn't mean they're not providing benefit in terms of fiber or other micronutrients, vitamins, minerals, antioxidants. But the metric that we look for is the ability to affect nitric oxide production. And there's very few products out there. In fact, I would venture to guess that only my products, and maybe a couple of others, provide sufficient amounts of nitrate in these green products or beet products that can actually lead to some measurable output of nitric oxide production.
So, Dr. Bryan, you say you're doing a lot of testing on this stuff, and that's wonderful. And I'm curious, are you testing it in a lab? Are you testing in people? Because what would be a real interesting to think about is, like, as you mentioned, me consuming nitrates dietarily may not be the same as you consuming nitrates dietarily based on our microbiome. So I'm curious if you're using a wide array of people or what exact mechanisms. And then also the reason I'm asking is, like, how do we test it? Should we be using nitrate sticks in our saliva or in our urine, or what would be the most proven method?
Well, that's a very good question. So we start with kind of the basics. So we test the products because there's no use in testing these products in human if the products themselves that we're administering don't contain what's required for the body to convert that to nitric oxide. So that's the first thing we do. We test this through HPLC that quantifies the amount of nitrate and nitrite in these products. And again, 90 to 95% of the products out there don't contain any detectable nitrate or nitrite. So there's no need to go do any further testing beyond those because they cannot work. They will not, and they cannot work. So we put those in a category by themselves. And then what we do is we take, if this particular product contains a certain amount of nitrate, then we know that the person that we're administering this to has to have the right oral microbiome, has to have sufficient stomach acid production, in order for the human body to take that nitrate in that product and metabolize it into a bioactive form of nitric oxide that can dilate blood vessels, improve athletic performance. So in those products, we take a wide variety of people, and then we give it to them. We can start an IV and we do serial blood draws, and then we look at the ability of the body to increase either plasma or salivary levels of nitrite. And so if they increase salivary levels of nitrite, then that tells us that the bacteria are present. So when you consume these products, it takes at least 90 minutes. So you got to consume it, it's got to be swallowed, it's got to be absorbed in the gut, transported to our salivary glands. We got to secrete the nitrate in our salivary glands. The bacteria have to respire on it to convert it from nitrate to nitrite. Then we got to swallow our own saliva and get nitric oxide in the acid environment of the stomach. So what we're finding is even if you take these products that have nitrate in, whether nitrate capsules or beetroot products, but people are using mouthwash or fluoride, or they're taking in acids, they don't get any nitric oxide benefit from those. So in that case, it's difficult, if not impossible, to determine who would respond with better performance or better blood pressure lowering effects from those products, because everybody's different. Your microbiome is completely different than mine. You may be taking in acids or may have achlorhydria for whatever reason, and my body may be able to produce stomach acid. So I'm going to get a much better effect from that type of product than you would, and some people are not going to get any effect at all. And that's the problem I have with a lot of these companies calling their products nitric oxide products, because by our metric and how we define nitric oxide activity of certain products is completely different than any other company out there. And they don't like that because it's basically telling the truth that their product may work in 10 to 15% of the population. And I'm not interested in providing a product that works in 2 out of 10 people. It's not what I think. Right. We understand the science to the extent that we create nitric oxide in every single person that takes our products. We control and dictate the metabolic fate. We release nitric oxide, whether you have the right bacteria, whether you have stomach acid, whether you're using a fluorinated toothpaste, whether you have endothelial dysfunction or not. Our products produce nitric oxide gas.
So would this make an argument for a first-line intervention for some people being dietary acid, like enzyme and dietary stomach acid, like HCl, and some type of a probiotic, maybe even prebiotic, as being kind of a first-line intervention to start rebuilding that aspect of the system?
Yeah, so the oral bacteria are completely different than the gut bacteria, right, by design. So most probiotics on the market are designed to restore the gut bacteria, lactobacillus, a lot of the communities that we've identified. But what we're finding through our research is lactobacillus in the mouth shuts down nitric oxide production. And most pre and probiotics that I've tested on the market do absolutely nothing to the oral microbiome. In fact, I've submitted a number of patents on this because we know which bacteria are responsible for this nitrate metabolism into nitric oxide production. And they're not found in any probiotics. You know, the FDA wanted us to do long-term safety studies on these non-pathogenic commensal bacteria, which is somewhat humorous, but anyway, those are the regulatory bodies. So to answer your question, we're still trying to figure that out. How do we restore the oral microbiome in the absence of mouthwash use or fluoride exposure? And we're starting to get a good handle on that. And, you know, what we're finding is the lozenge that we generated, you know, most pathogenic bacteria are sensitive to nitric oxide. And because our lozenge has a resident time of about 5 to 6 minutes in the mouth, it kills the bad bacteria, helped restore the diversity of the oral microbiome, and improve nitric oxide production on its own. And it also recouples the enzyme in the lining of the blood vessel. So I think, and our strategy is always, look, let's give the body what it needs, get out of its way, and let the body do its job. But some people, you know, it becomes their habit. They use a mouth rinse. They've used fluoride toothpaste for 20 years. And some people have acid reflux to the extent that it's almost impossible to wean off antacids because of the painful acid reflux or the gastroesophageal reflux disease and the Barrett's esophagus. So we have to be able to provide these people a source of nitric oxide because their body can't make it. And their body's not going to make it as long as they continue to take these products.
Interesting. So are you able to share what your first-line intervention would be as the current level of knowledge and data stands to repopulate the oral microbiome?
Yeah, so what we're finding is nitrate itself. So if you throw in some more green leafy vegetables, these are what's called nitrate-reducing bacteria. So they're facultative anaerobes. And what that means is if oxygen's around, they'll respire on oxygen. When oxygen becomes limited, and these are deep in the crypts of the tongue, on the dorsal part of the tongue, the back of the tongue. So when oxygen becomes limiting, then they can respire on nitrogen. And they do this through the 2-electron reduction of nitrate to nitrite. So simply by providing either nitrate or nitrite can help wake up these nitrate-producing bacteria and give them more substrate to respire on. And then number 2 is we have to restore stomach acid production. Your body cannot heal without stomach acid. You can't break down proteins into amino acids. Hen acids are the basis for foodborne allergies, most autoimmune disease. So we have to be able to make stomach acid. We need stomach acid to absorb things like magnesium, iron, selenium, chromium, iodine. And so people who can make stomach acid become deficient in basic micronutrients because the parietal cells in the stomach are designed to secrete hydrochloric acid to acidify the lumen of the stomach so you can break down proteins into amino acids and you can absorb basic nutrients like B vitamins. And when you shut down stomach acid production, you become nutrient deficient. You develop H. pylori, which are ulcer-causing bacteria, and you can't break down proteins into amino acids, so you develop autoimmune disease. So we have to be able to restore stomach acid. And the chemical reaction in the pyloric cells to make stomach acid requires iodine, requires zinc, requires sodium bicarb, sodium chloride, and some B vitamins. So we have to supplement these nutrients that are missing in people who have been on acids. So now the parietal cells have what they need to secrete stomach acid, and you can overcome reflux disease. So reflux is not a symptom of overproduction of stomach acid. Reflux is a symptom of insufficient stomach acid production.
Phenomenal. So here's the question of the day. If I want to maintain teenage erections into my 90s, what should I be doing on a day-to-day basis?
Well, that's the $100,000 question, right? Because I think we all want to live a long life, a full life, and free of disease. And there are a number of things that contribute to that. But I think, I always tell people nitric oxide is foundational. If there's one thing that you should focus on, kind of the foundational aspect of longevity and performance, it's nitric oxide. But it's not a silver bullet. It's not the only thing. It's not an end-all, be-all, cure-all. But here's what we know from the science, that without adequate nitric oxide production, anything you do from this point on is going to have limited clinical results. So whether you're doing caloric restriction, intermittent fasting, sauna, exercise, if your body can't produce nitric oxide, then you're not going to get induction of mitochondrial biogenesis from caloric restriction or intermittent fasting. You're not going to get the adaptive effects of exercise without sufficient nitric oxide production. And then, when we talk about kind of the objective measures of longevity, the telomeres become shorter. The length of the telomeres, the ends of the chromosome, are dependent upon the cell's ability to produce nitric oxide to activate an enzyme called telomerase to prevent telomere shortening. The cell can't make mitochondria, which are the energy production organelles of the cell, without nitric oxide. And nitric oxide is what controls the efficiency of mitochondrial ATP production. And then the other aspect of longevity in regenerative medicine are stem cells. We're constantly wearing ourselves out, and it's the job of our stem cells to mobilize, differentiate, repair, and replace dysfunctional cells. And nitric oxide is the signal that tells our own stem cells to mobilize and differentiate. So aging is really just wearing ourselves out in the inability to repair and replace tissues. It's not the loss of stem cells, it's the loss of stem cell function. And that stem cell function is dependent upon the cell's ability to produce nitric oxide to mobilize endogenous stem cells to go and repair. So again, everything we know about human performance, longevity, health, and wellness, nitric oxide is foundational. But if you have low testosterone, nitric oxide is not going to help that. If you have low thyroid, nitric oxide is not going to fix that. If you got dental infections or exposed to other toxins, nitric oxide is not going to affect that. So we have to dig a little bit deeper and figure out and optimize each individual, and that's the whole basis of personalized medicine. But unless we restore the production of nitric oxide, then nothing else is going to work.
So if I I guess where my question was going on this, on a day-to-day basis, I've seen you advocate for fasting. I've seen you advocate for, we may call it time-restricted feeding. Is there any daily interventions that you currently implement? I've seen you post about your morning routine, your nighttime routine, anything specific like, hey, here's some actionable where the rubber meets the road things that every man, woman, and child should be doing right now, ultimately to improve their body's ability to produce endogenous nitric oxide.
Yep. Well, everybody's different, and I'll tell you because I can only comment on what works for me. As I mentioned, I turned 50 in November, but I haven't been sick from an illness in more than 20 years. Haven't lost a day of work due to illness in 25 years. So, but I pay attention to my body. I know when my body's getting run down, and I take proactive steps. But just on a daily basis, number one, sleep is very important. I try to get 8 hours of sleep a night, but I travel every week. I'm on an airplane. Sometimes it's very difficult, different time zones, different parts of the world. But every night before I go to bed, I take magnesium, 700 milligrams, because magnesium is needed to produce nitric oxide, and magnesium's a cofactor in, I think, 87 biochemical reactions. So we replete magnesium.
Any specific chelate?
I use magnesium glycinate. I've tried different salts, magnesium citrate, magnesium malate. All of them. I mean, they're salts of magnesium, right? So they completely dissociate once you take them, and they're absorbed in the body and in the bloodstream. I take a product that mobilizes my own stem cells. So when we sleep, we repair, and I want to make sure that my stem cells are mobilized. So I take my lozenge at night. I take a product called Stem Regime that's plant-based that mobilizes stem cells. And then I take a CBD. The endocannabinoid system is relaxing. It stimulates nitric oxide production. So I take a CBD product to help me relax, to turn my brain chatter off, and to help me get deep sleep. And then sometimes I'll take things like melatonin really doesn't work for me, threonine, valine, some of these other neurotransmitter amino acids to help with sleep. And then in the morning, I wake up, and my first thing is I take chlorella and spirulina that have, these are algae products that contain many basic micronutrients. I've quantified the nitrate and nitrite in them, so they're providing a bioavailable source of nitric oxide. And then I get an infrared sauna, and I sit for 30 minutes at 170 degrees. So I mobilize my toxins. I use that time for prayer and for just gratitude. And I think we have to start our day with prayer and gratitude, the fact that we woke up and, get to live another life, another day in our life. And then I exercise. No matter where I am, I try to go to the gym. I do cardio, 20, 30 minutes of cardio. I do resistance training. Then I take a multivitamin, basically dependent upon my individual needs. But I think and then, when I feel my body running down, I got a hyperbaric chamber in my home. And so I'll do hyperbaric, which is known to improve oxygenation, mobilize stem cells, improve nitric oxide production. Those are the basics.
Talk to me about that. Talk to me about the hyperbarics, because that's a big one. I think there's a lot of people out there right now seeing the value, noticing the value. Are you doing it specifically from a place of regeneration with regard to nitric oxide, or just all over tissue repair?
Well, all over tissue repair. The clinical data on hyperbarics is really indisputable. It's a very effective treatment for non-healing wounds, for concussion, for any type of what we call hypoxia or ischemia. So hyperbaric just basically refers to high pressure oxygen, right? You get into this tank, you basically descends you to, anywhere from 2 to 3, 4, 5 atmospheres. So what that high pressure does is it forces oxygen delivery to every cell in your body. And really, this is mainly dissolved oxygen, not oxygen bound to hemoglobin. So you improve the oxygenation or the concentration of dissolved oxygen simply by applying high pressure. And then it leads to wound repair and wound healing. And this was data, I think, published in 1982. Hyperbaric oxygen stimulates stem cell release because it improves nitric oxide production. So to make nitric oxide, we need oxygen as part of an essential cofactor. So if we push oxygen and we can maintain some coupling of the NOS enzyme, it improves nitric oxide production. Nitric oxide then mobilizes stem cells, leads to tissue repair and wound healing. Mechanistically, that's how that works. But obviously, I don't have any wounds, but I know that it's beneficial and it's a prophylactic measure for me. So especially during the winter months and the height of flu season or any other type of viral infection, then viruses don't like oxygen, right? It's people who have compromised blood flow, decreased nitric oxide production, that are susceptible to the seasonal flu, to COVID. And those are the people that get sick and sometimes die from respiratory viruses. So what I want to do is I want to maintain optimal tissue oxygenation. And we do that through adequate nitric oxide production. Hyperbaric oxygen does it, and then maintaining normal acid-base balance in our body.
I love it. So much wisdom right there. I have a question that may be completely wrong wording of the question. I was doing some research this morning, and I saw something that explained that once the glycocalyx is worn down, proteolytic enzymes can eat away, misquoting that word, but eat away at the endothelium. And so I'm very curious if I'm on the right track with that mechanistically, and where I'm really going with this is, if I'm taking supplemental proteolytic enzymes, does that in any way negatively impact the glycocalyx or the endothelium?
Possibly. Proteolytic enzymes, I think, are important. And what they do is they break down kind of peptide fragments or foreign proteins in the blood supply. So if we have poor digestion, we can have these kind of agglutinated type of protein particles that may cause damage. So then if you take a protease, for example, or some proteolytic enzyme, it helps break down that into constituent amino acids. Now, does that also lead to the breakdown of essential proteins on the glycocalyx? I'm not aware of any evidence to that, but I think, people have to and what I try to inform people is, look, understand the mechanism of things you're doing. Because it's like, the best example is people use mouthwash. They go, why use mouthwash? Well, as my dentist told me to do that. Well, when you understand what mouthwash is doing, then you probably, once you understand the mechanism and it's destroying the entire oral microbiome, not just the bad guys, then you're probably not going to do that. If you're taking protease enzymes or proteolytic enzymes, and where you don't have any kind of foreign protein globules floating around, and now you're starting to impede upon normal protein structure and function on the glycocalyx and endothelium, then maybe you should back off the proteolytic enzymes. But there has to be a reason people take these. You don't just take it, and I'm not a big fan of taking something, every day for the rest of your life unless we understand mechanism. And so in terms of nitric oxide, I certainly take our product every day, and I've been taking probably 15 or 20 years because I know mechanistically what it's doing. I know what my body's exposed to that may lead to a loss of nitric oxide production, and I certainly want to prevent that. But because of how we do it and the way we do it, there's no downside to it. We're not shutting down our own endogenous production. We're actually improving the body's ability to make it. So by way of what we do, we see no downside with taking that. But with the protease enzymes or the proteolytic enzymes, I just caution people, just be careful and pay attention to your body.
So there's some enzymes that you may or may not have heard of, like serrapeptase, nattokinase, lumbrikinase, that have been shown to have positive effects on atherosclerosis and, call it hardening of the arteries and other fibrotic tissue.
Yep.
So there's known benefit to that. And I'm just curious if it also, like many things we do, also comes with a potential negative of like, is it actually doing harm to the glycocalyx or endothelium? And in which case, I don't know if anyone's ever seen data on it. I certainly haven't. I was looking, just that's why I wanted to kind of throw that out.
Yeah, no, I'm not aware of any data on it. I mean, most of these products like nattokinase and some of these, if they're natural products, if they're derived from nature, they're extracted from plant products and if you go back to traditional Chinese medicine, most of these are natural products. And I think the human body is designed to deal with natural products, naturally produced proteins or agents. What the human body is not designed to ever see are synthetic compounds that are man-made, things that inhibit cholesterol production, things that inhibit COX-2 or these most synthetic drugs. Our body always reacts to that because it's inhibiting a biochemical reaction. When you do that, there's always a shuttling of metabolic byproducts, and you get a buildup of certain things. And those are what we call side effects.
So now you brought up a hot topic right there, Dr. Bryan. I'll bring it up. So you said things that block cholesterol pharmaceutically, and I've heard you mention in passing some thoughts perhaps around taking things like statins or other potentially cholesterol blocking medications. What are your thoughts and opinions on those? And you could answer however you want through the lens of the nitric oxide system and endothelium, or just an overall opinion on the topic.
Well, I'll speak from a basic science perspective and understanding mechanism of how the human body works. I have a degree in biochemistry and a PhD in molecular and cellular physiology. So I think I've learned over the course of my studies and,
Paid your dues.
25 years in doing basic science research, that the human body naturally produces cholesterol. And so it's always a bad idea to get in the way of a normal human process. So first of all, I've never understood it because cholesterol doesn't cause heart disease. Cholesterol doesn't cause you to have a heart attack. So why would you intentionally inhibit the body's regulation of cholesterol? And so that there's crosstalk, right? So if we're not getting enough cholesterol from our diet, we need cholesterol, right? We need cholesterol to make cell membranes. We need cholesterol to make vitamin D. We need cholesterol to make testosterone and estrogen. And if we're not getting cholesterol from our diet, then our body goes, hey, I need more of this and I need to make it because I'm low in testosterone, I'm low in vitamin D, I'm low in estrogen. The cell membrane of my cells is, losing its fluidity because there's not enough cholesterol in that cell membrane. So when you inhibit the endogenous production of cholesterol, there's consequences. Number one, we develop low vitamin D. I mean, there's an epidemic of low vitamin D in not just America, but people around the world. And if you can't make vitamin D, you become immunocompromised. It's a critical hormone. Then the other thing is, testosterone and estrogen are made from a cholesterol backbone. And if you get your cholesterol below 200, then you don't have enough cholesterol to make testosterone and estrogen in your testes or ovaries. And now what we're finding is, and this is the clinical data from people who have been on statins for a number of years, is developing diabetes because it's destroying insulin resistance. So a lot of intracellular signaling is dependent upon the integrity of the membrane, the cell membrane. There's what's called a 7 transmembrane receptor where it binds insulin and through this intracellular messaging can activate a number of protein kinases and lead to glucose uptake and a number of cell signaling aspects. But if you have too low a cholesterol, you lose that signaling aspect. So insulin no longer signals. You develop insulin resistance diabetes. These drugs are also mitochondrial toxicants. They shut down the energy production in the cell, mitochondria. You produce the Warburg effect, which basically leads to cancer. And so those are just the clinical observation you're seeing with people who have been on statins for a number of years. So what I like to do is take important clinical observations, then work backwards, understanding what we know about physiology and biochemistry, go, oh, well, this happened because of this, and this happened because of this. And that's much different than predicting what's going to happen, because a lot of the predictive analysis don't pan out. And I think we've certainly witnessed that over the past 3 or 4 years.
Yeah. And so you said that cholesterol doesn't cause cardiovascular disease. In your opinion, what does cause cardiovascular disease?
Well, I think what the data tell us, it's a functional loss of nitric oxide, because once the endothelial cells can no longer make nitric oxide, not only do they lose the barrier function of the endothelial cells, so you get transmigration of fats and monocytes and neutrophils, which cause inflammation, oxidative stress, and immune dysfunction. And then you use smooth muscle proliferation, you get plaque deposition. That plaque becomes unstable and the plaque ruptures, and that's a heart attack or stroke. But
right. So is it a side effect or a cause?
Yeah, nowhere in that process is it because of high cholesterol. 50% of the people that die from sudden cardiac arrest have normal cholesterol levels. I mean, so it makes no sense. It's the wrong target to go after. And I think from what I try to do is look at things through the lens of a risk-benefit analysis. So what is the benefit of taking or doing a certain thing, and what's the inherent risk of doing that? And if the risk outweigh the benefits, then it's a no-brainer. You don't do it. So in the risk analysis of statin therapy, what are the benefits? There's really no benefits. Number one, the clinical data showing statins as a primary prevention are very poor. Secondary prevention, very poor. Tertiary prevention, maybe. If you got a patient that suffered 1 or 2 heart attacks, you put them on a statin, maybe it protects from subsequent events. But again, very little benefit. So what's the risk? Where you're going to develop low vitamin D, low testosterone, diabetes, perhaps cancer, and no protection from heart attack or stroke. think to me, the answer is quite clear if I would take a statin or not. And the answer is absolutely not.
Yeah, so you said that nitric oxide, it seems as though nitric oxide is certainly involved in the process, but you think that's the cause, not a symptom? I mean,
well, I think it's almost a feed-forward mechanism. And I say that because the data tell us that endothelial dysfunction precedes plaque deposition, plaque instability, and plaque rupture. And that's the whole sequence of heart attack and stroke. So, and again, this comes from clinical observation, that some people have heart attacks, they go in for an angiogram, they've got less than 10% stenosis or occlusion of the coronary arteries. The next day they have an MI or a myocardial infarction. So what that means is even though they had like 10%, less than 10% stenosis, the vulnerability of that plaque was so high that even with 10% stenosis of the arteries, that plaque ruptures and causes heart attack. So again, it's not the cholesterol in the plaque, it's the instability of the plaque that's determined by the inflammatory cascade, the oxidative stress, the smooth muscle proliferation, and all that's controlled by nitric oxide. So if you have good nitric oxide production, good endothelial function, you maintain barrier function, you prevent monocytes and neutrophils from sticking to the lining of the blood vessels, you prevent cholesterol transport across the endothelium, and you completely inhibit inflammation, oxidative stress, and immune dysfunction. And that's what causes cardiovascular disease. That's what causes plaque instability, plaque rupture, and heart attack.
Incredible information, Dr. Bryan. Can you tell us more about your supplement line and where we can find it and hear more about you? I know you've got an incredible blog that it looks like you write yourself, and it's a great resource for our listeners, which I'll link to in the show notes. But if you can tell us
the first place I send people, look, I'm not here to sell products. I'm here to provide education and information. So I encourage people to go to my YouTube channel, subscribe, because it's my objective to educate and inform people so that each individual can make informed and educated decisions on what's best for them. It just so happens we make product technology that works. But so my YouTube channel, Dr. Nathan S. Bryan, Nitric Oxide. I've got an educational website where, as you mentioned, I do a monthly blog. I write the blogs myself. I don't contract this out because I try to pay attention to what are the hot topics, what's practical and timely, and I can provide kind of my perspective. And most of it's focused on nitric oxide. There may be some times where there may be some topics that come up that I think is worth mentioning. But that website is drnathansbryan.com. Again, it's educational. I'm not trying to sell you anything. But for those interested in our product technology, it's n101.com. That's the letter N, the number 1, the letter O, number 1.com, as in one nitrogen, one oxygen, which is nitric oxide. So n101.com.
And I think, rather than, directly selling your products to us, what you've done is you've become a trusted authority. And, sounds like you're the type of person we can trust in this topic. And when you say, hey, this product makes sense, then I think myself and a lot of listeners are going to want to support. So, Dr. Bryan, thank you so much. We'll link to that and so much more from this podcast in the show notes. I truly appreciate what you're doing, your commitment to helping us all live a better, longer life, and ultimately have great sex into old years. So thank you, sir. I appreciate your time.
Thank you, Ben. It's been a great honor and pleasure. Thanks for having me.
And that's a wrap, ladies and gents. Thank you very much for tuning into the Muscle Intelligence Podcast. I realize you've got so many incredible choices out there, and I'm incredibly grateful that you choose me and you choose us here at Muscle Intelligence. Thank you to Dr. Nathan Bryan. If you want more information or you want some of the things we talked about, you can check out the show notes at muscleintelligence.com/podcast. And that and so many other incredible podcasts that I've done over the last 10 years. This podcast has been in existence since 2013. And we've got just incredible guests. And it's not just about muscle anymore, is it? It's about muscle. It's about longevity. It's about health optimization. It's about showing up at your highest and best for what matters most to you. Gentlemen, ladies, thank you for being here. And again, the podcast is brought to you by yours truly and the team at the Muscle Intelligence Coaching Community. We're so blessed to work with an incredibly motivated group of men over 40. Gentlemen, we want you to show up at your best for your family, for your finances, and for your passion, for your vocation. And if you're someone who's curious, you can head over to muscleintelligence.com and just join our newsletter, and you can hear me talk about all the things that are pressing in my life as a man over 40. And if you're someone who's ready to take action right now and ultimately change your life in the next 90 days and beyond, go to muscleintelligence.com/apply. That's APPLY. Gents, ladies, have an amazing day. I love you. Don't forget to subscribe, leave me a review if you want to hear about something more. And I will talk to you soon. We'll see you in the next podcast.
Thank you so much for tuning into Muscle Intelligence. If you enjoyed today's episode, please be sure to share it with at least one person you know. And make sure you're subscribed so you never miss an episode. This podcast is for information purposes only. The statements and views on this podcast are not medical advice. This podcast, including Ben Pakulski and the producers, disclaim responsibility for any possible adverse effects from the use of information contained herein. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. This podcast may contain paid endorsements or advertisements for products or services. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. If you think you have a medical problem, consult a licensed physician.